Now that we've defined how to see when a function is increasing and decreasing and how to find critical points, we're going to learn about how to find the maximum and minimum using equations. We're going to look at relative maximum minimums first, and then we'll look at global maximum minimums. Let's say the function x squared plus 14x minus 8. This function is a parabola, so it's going to have a minimum point at the bottom, and that's going to be it, right? It's not going to have a max because it goes on forever, and there's no interval. So how do we find that? First, we should find the critical point, because this is going to be a critical point. It's going to be flat right here. So we have to derive this and say this is f of x. Then we'll call this f prime of x. And derive it, we'll get 2x plus 14. And we have to set this equal to 0 because we're trying to find when the slope is 0. So 2x equals negative 14 and x equals negative 7. So we know that there is a minimum at x equals negative 7. This is pretty simple if it's a parabola function because you know that it has one minimum and you know where it's at. But you know that if this was negative x squared, the parabola would look like this. So this would be just one maximum up top, right? But what do you do when things start getting more complicated and there's more than one maximum, more than one minimum if it's a more complex function? So let's say we have this function here, which got a lot more going on. We got 3's as exponents. We got 2x squared, right? Got a bunch more going on. How do we find the local minimum and maximum here? We do the same thing. We start off the same with critical points. We have f prime of x equals, you derive this function, you get 12x squared plus 4x minus 16. And then you have to set this equal to 0, right? So this is a lot easier if we factor it. We'll factor out a 4 first. We'll get 3x squared plus x minus 4 equals 0. We could divide both sides by 4. So this 4 will go away. And then we have to factor the inside of this. And if you factor this, you'll end up with 3x plus 4 and x minus 1. So you'll be left with the critical points of x equals 1 and x equals negative 4 over 3. And then what are we supposed to do with these values, right? We have our critical points, but we don't know if they're maximums or minimums or what. In general, if you have a function and it is increasing and then decreasing, you're going to have a maximum up here, right? Because if the slope changes from positive to negative, it's going to look like this, and there's going to be a maximum up here. And if it's decreasing and then increasing, it's going to look like this, right? Because the slope is down and the slope is up. So you're going to have a minimum value, right? So since we know how to determine if a function is increasing or decreasing, what we do is we take our critical points, we put them on a table, and we see how the slope is changing. So we have our critical points of x equals 1 and x equals negative 4 over 3. So just like when we were trying to find if the slope was increasing or decreasing, we're going to make a number line using our critical points, right? We have x equals 1, so we'll put 1 right here. And we have x equals negative 4 over 3. We'll put that over here. So the slope, when x is less than negative 4 over 3, we'll plug in, I don't know, negative 2, right? If we plug in negative 2, we'll get a negative value here times a negative value here, and a negative times a negative equals a positive. So the slope, when it's less than negative 4 over 3, is going to be positive. If we plug in a number in between negative 4 over 3 and 1, let's say 0, we'll get a positive number times a negative number, which is just going to end up being negative, right? And then if we plug in a number bigger than 1, let's say 2, we'll get a positive number times a positive number, and that'll end up being positive as well. So we see the slope here is positive, it's increasing until negative 4 over 3, and then it's decreasing until 1, and then it's increasing again. So since it's changing from a positive slope to a negative slope at negative 4 over 3, you can see that this is a maximum. And since it's changing from a negative slope to a positive slope at 1, you can see this is a minimum. So if you're looking for relative maximums and minimums, you find your critical points, put them in a number line, and see how the slope is changing in between the points. We'll look at a couple more examples, and then we'll move to absolute extrema and see how you find that. So let's say, for example, we have this function here where f of x equals x squared minus 9 all to the power of 2/3, right? And we have to find any local extrema in this function. To do this, same thing as always, we have to find the critical points, you have to derive it. We'll get f prime of x equals, this is chain rule, you bring the 2/3 to the front. So we have 2 over 3 times x squared minus 9 to the power of negative 1 over 3 times, and we have to derive the inside, and we'll get 2x. We can simplify this, we can move this down to the bottom because it has a negative exponent, and we can put this on top because it's multiplied. So we'll get 2 times 2x over 3 cube root of x squared minus 9. And if we want to simplify this more, we can make this 4x on top. Now that we have our derivative function, we have to plug in numbers to get 0. Obviously, to make the top 0, we just have x equals 0. In addition to any point where x's could be zeros, any point where the derivative is undefined on a function also works as a critical point. Like example, if your function looks like this and has a sharp corner, since the corner is sharp, the derivative is undefined, but this could still be a negative. So we also have to find points where this function could be undefined, and to do that, we make the bottom equal 0 as well. So in this case, to make the bottom equal 0, we would have to make this part equal 0 here. So our x would be -3, and our x would be 3, right? Because it's x squared minus 9 would have to equal 0, and 3 squared is 9, 9 minus 9 is 0, and -3 squared is 9, and 9 minus 9 is 0. So we have our critical points, and we have our function, so we have to make our table. So let's put that down here. This one's going to be kind of big. So we have 0, we have -3, and we have 3, right? So to find the slope of this part, we'll plug in a number smaller than -3. Let's say -4. On top, we'll have 4 times a negative number. We'll get something negative. On the bottom, we'll have something positive inside this cube root. So the whole thing will just end up being positive. We'll have a negative number over a positive number. So this slope is negative. In between -3 and 0, if we plug in a number that's bigger than -3 and smaller than 0, let's say -1, we'll have a negative number on top and a negative number on the bottom. So this will end up being positive. If we pick a number in between 0 and 3, let's say 1, we'll get a positive number on top, and this down here will be negative. So we'll end up with a negative number on bottom, and a positive over negative will end up being negative. And if we plug in a number greater than 3, we'll get positive on top and a positive on bottom. So this will end up being positive. So we have decreasing slope before -3, increasing slope in between -3 and 0, decreasing from 0 to 3, and increasing from 3 and beyond. So the minimum is when the slope is changing from decreasing to increasing, right? So that happens at -3 and at 3. So we're going to have minimum values at x equals -3 and x equals 3. And a maximum is when it goes from increasing to decreasing, and that happens right here at 0. So we're going to have a maximum at x equals 0. So to find the local minimum and maximum, you find your critical points, you plug in, you see when your slope is positive and when your slope is negative, and wherever the changes are, you have either a maximum or a minimum. So next, we're going to look at absolute or global minimums and maximums and how to find those. To find the absolute maximum and absolute minimum in a function, we don't really care about slope. The reason is because if we have a function and it's going like this, you could see that, okay, this is a positive slope, this is a negative slope, so this is a maximum, right? But the same thing is true up here. And if you're looking for the same thing for a minimum, you could be like, okay, this is a negative slope, this is a positive slope, so this is a minimum. But the same thing's true right here, right? So if you look at these values, and we look at it the way we've been looking at it, with the decreasing and increasing and when it changes and all of that, it tells us where the minimums are and what the maximums are. But if we're looking for that absolute, the global minimum and maximum, we have to find what the value is, what the highest value is, and what the lowest value is, right? So to do that, we can kind of ignore the slope and just plug in the x values and get the y values. And wherever we find the greatest y value or the least y value, we're going to end up with our absolute maximum and absolute minimum. So I'll show you what I mean. So let's say we're looking at this function here on the interval -5 to 2. So we're looking at 4x to the third plus 2x squared plus 7 on the interval -5 to 2. So how would we go about solving this? First thing we have to do is find all the critical points, which we're going to derive this function. We're going to get f prime of x equals 12x squared plus 4x. 7 goes away. And then we can factor this, and we'll get 4x, 3x plus 1. All right, so this is our f prime of x function. Now, if we set this equal to 0, we'll get x equals 0, because this first part will be 0, and for the second part to be 0, x has to be -1/3. And since this is on a set interval of -5 to 2, we also have to include the start point and the end point as critical points, because let's say it starts at -5 and it's up here, and all this stuff happens and it ends at 2 down here, right? This would be the absolute minimum, even though the slope doesn't equal 0 here. Since it's the end of the function, it could just go down, 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 and down, and then end at the lowest point that it reaches. So we have to include -5 and 2 as critical points as well. And from here, since we're looking for that absolute maximum and the absolute minimum, we don't have to know when it's increasing and decreasing. We don't care. We're just looking for the highest value on this function and the lowest value on this function. So how would we do that using these critical points? What we would do is we would plug each of these critical points into our original function and see which one gives us the highest y value. So we'll make a table, label it x and y, and we'll put in all of our critical point values that we have. I don't really want to plug in -5, -1/3, 0, and 2 into this function up here, because you know it was 4x to the third and 2x squared. It's just a lot. So for this part, you can use a calculator. I'm sure your teacher will let you use a calculator for an equation like this. And if we plug in -5, we get -443. If we plug in -1/3, we get 7.074. If we plug in 0, we get 7. If we plug in 2, we get 47, right? So if we look here, and we're looking for the absolute minimum and the absolute maximum, we're just looking for the smallest value that we have and the largest value that we have out of our critical points. So our minimum in this case is going to be -5, -443, right? Because we're looking for the whole point, the x value and the y value. And if you're looking for the absolute maximum, you're going to look at our largest number, and you're going to get 247. So you find the critical points for x values you could use. And then for the y values, you plug them in and you see which one is your highest because that's your absolute maximum. And you plug in and see which one is the lowest because that is your absolute minimum. We'll look at a couple more of these, but it's pretty straightforward. For our last example, let's say we have the function f of x equals 5x cubed plus 14x squared minus 4 on the interval -2 to 1. And we're trying to find the absolute maximum and minimum on this interval. First thing we have to do, as always, is find the critical points. So f prime of x equals 15x squared plus 28x. The 4 goes away. We could factor out an x. So we have f of x equals x times 15x plus 28. And if we set this equal to 0, we'll get x equals 0 and x equals -28 over 15. So our critical points are going to be -2, -28 over 15, 0, and 1. So let's make our table. We have all of our critical points here. We have -2, -28 over 15, 0, and 1. If you plug all of these into a calculator, into a table, you're going to get -2, 12. -28 over 15, you're going to get 12.26. For 0, you get -4. And for 1, you get 15. So once you have your values, you have to determine what your maximum is and what your minimum is. And we can say that our highest value here is 15. And our lowest value is a -4, right? So our absolute maximum is at 115. And our absolute minimum is at 0, -4. So that's it for this concept. You just have to find your critical points, make a table, plug everything in. We're moving on.